In the world of voice, the whole idea of switching takes on kind of a different meaning than the one we understand within the networking world. You have to appreciate that back in the old days, you used a concept called circuit switching. I mean, you would have an analog signal that would travel from one telephone to the next, and you literally, via hard circuits carrying voltage, would have to switch in order to get to the other phone so that they could talk to each other. Now, circuit switching is fine, but it's a kind of a concept that's faded out. There have been a number of different ways that we've tried to do switching in the telephone world. They have some older technologies which, thank goodness, are no longer on the Network Plus, but there's a couple that are at least made a quick mention of, and you need to be aware of them, if nothing else, as forms of switching technologies. So as we move out of circuit switching, we move more into a world of packet switching, which does give us some pretty strong similarity to what we see in the networking world. When we talk about packet switching, there are two big technologies you need to be able to go, those are packet switching. The first one is called frame relay. Frame relay's been around since the 1980s, and frame relay's job was to come up with a type of packet switching that didn't care about errors, but it was very, very quick. So frame relay has been around for a long time, and most of the time when you're buying, for example, a T1 line, people aren't going to say, oh, you want a T1 line. They're going to say, oh, do you want a frame relay line? Because everyone knows it's T1, but what you're actually paying for is the type of switching that's placed on top of it. Now, frame relay's been around for a while, but frame relay's faded out pretty heavily for something else called ATM. ATM stands for asynchronous transfer mode. However, ATM is a complete networking solution. ATM is what is used on, for example, our huge SONET lines that are the backbone of the internet. But even ATM has begun to fade out. The reason that ATM has a problem is that ATM was invented in the 1990s as some kind of do-it-all form of switching technology. It was designed to be able to handle voice and data and video and everything. Bottom line is in today's world, almost everything is now data. There's a little bit of pure voice, but even most phone calls end up running under voice over IP. So the whole idea of ATM, the beauty of it being able to do everything, has started to fade away. Today, when we start talking about switching technologies, we tend to think about switching technologies that are very, very IP-centric. And one of them right now is called MPLS. MPLS is designed really for IP-based networks, and it takes advantage of some really big mistakes that we made with ATM. For example, ATM, each one of its little frames are only 53 bytes long. That makes a big 1500 byte Ethernet packet end up being badly fractionalized as it has to be dispersed through an ATM network. Well, now Mike, it's not that the ATM packets were a mistake, it's just that they were also designed to work with voice. MPLS kind of fades all that away, and the beauty of MPLS is that because it is designed primarily to work within an IP environment, it doesn't matter whether you're sending data over a T1 line, over a DOCSIS cable modem, over DSL, satellite, or Ethernet, MPLS works for all of these. So MPLS is really what we see today more than anything else. Keep in mind that unless you're actually working for an ISP or a very large enterprise, the chances of you actually having to deal directly with any of these packet switching technologies is pretty small. Which brings us to the last and most interesting point. All of these packet switching technologies could conceivably eventually fade away in a world that we call all IP. We're getting to the point now where we're having Ethernet-based technologies that are so powerful, 10 gigabits per second, single mode fiber optics, they can run for miles, where in theory one day we could see a world where the entire internet is pure Ethernet. So all of the old telephone technologies that we've known and loved will eventually fade away. Now, there's plenty of people in the telephone industry who think I'm crazy, but there are large consortiums that are taking place even right now that are trying to come up with ways where all voice is going to be voice over IP, all data is going to be IP based, and it's going to be a big, happy IP world.